Hi guys, in this video we'll be looking at a question which reads as follows. A uniform ladder rests against a smooth wall as shown in the diagram. If a ladder weighs 200 newtons, the ground has a coefficient of friction of 0.4 newtons, and a person weighing 800 newtons starts to climb up the ladder, determine how far up the ladder they may go before the ladder starts to slip. The first step in this question is to draw the free body diagram. So we'll write in all of the forces which are acting here. First, we recognize that for this diagram we have a smooth wall, and the ground is a rough surface, rough ground, because it has a friction coefficient. Okay, so the next thing here is we know that there is several forces acting here. On the smooth wall there will be a normal force which acts due to the wall, here, so N wall. We'll have a normal force due to the ground. So normal force due to the ground. And the ladder will tend to slide towards the left. So there will be a reaction friction force going this way. Here F ground, you can call it FG if we want. The ladder, so because the ladder is uniform, as we see across the top here, because it's uniform, then we know that there is going to be a load in the center of the ladder. So that will act down, and it will be 200 newtons. Also, we have a person weighing 800 newtons climbing up. So for simplicity, we'll assume that the person is in line with the ladder. So that person will climb up the ladder. We'll have a force which acts downwards, and the size of that force will be 800 newtons. The person would be walking or going up that ladder at some kind of distance x. So we'll write that distance here. Which will correspond to some kind of distance along the ladder here. So we could call this x prime, or that will do. Alright, so that's our free body diagram, and now from the free body diagram we can try to analyze what's going on in this system. Okay. So the next step is to look at the equilibrium of forces on the ladder. So for the ladder in the x direction, we can look at the conservation of forces. In the x direction, the ladder is stationary, so the sum of forces in the x direction will be equal to 0. Then we can write down each force in the x direction. So we've got Fg going towards the right, and Nw, or N of the wall, going back towards the left. This is going to be equal to 0. Okay, second, we can look at the summation of forces in the y direction. So this should be equal to 0. And in the y direction we have Ng going up, we have 800 going down, 200 going down, and there is no other forces acting in the system. So that's equal to 0. So from that we get Ng equal to 1000. Okay, and a couple more things here. So we also know that we want to get the person to go up the ladder, and we want it to get to a position where the friction force is at a maximum value. If the person goes any further up the ladder, then we would see that the ladder slips. So we know that Fg is going to be at its maximum value. There is a relationship between the maximum friction force and the normal force, which is from F equal to mu n. So here we can write Fg equal to mu, which was 0.4 times ng. Okay. Lastly, we also know about the overall moments which are in this system. So for conservation of moments, we can write that the summation of moments around a point, so this time we're going to pick point G at the ground. So the sum of moments at point G should be equal to 0. We'll take anti-clockwise as positive. And from here we get 800 times x trying to rotate that system clockwise, so this is a minus 200, so that's the force, times a distance of, well, if this is 5.2 going from here to here, then the distance to the middle of the ladder in the x direction will be half of 5.2, or 2.6. So 200 times 2.6, and then plus in wall times 9 meters. This should be equal to 0. Alright, so now we've got 4 unknowns and 4 equations, and we can solve this system of equations. Okay, so we'll name each one of the equations. So we'll call this one equation 1, equation 2, equation 3, and equation 4. We can substitute equation 2 into equation 3. Alright, so substituting equation 2 into equation 3, we get Fg equal to 0.4 times 1000. So Fg is equal to 400. We can call this equation 5. And we can substitute equation 5 into equation 1. So there we get 400 newtons minus Nw equal to 0. So therefore the normal reaction from the wall is equal to 400 newtons. So we've taken 400 and put it into here. Sorry. Right, so we can call that equation number 6. And now that we know the normal reaction from the wall, we can substitute that back into this equation here, equation 4. So equation 6 into equation 4. And we get minus 800x minus 200 times 2.6 plus Nw times 9 equal to 0. Nw was equal to 400. So we can replace that with 400 and then rearrange and solve for x. So this will be 200 times 2.6 minus 400 times 9 divided by 800, negative 800 that is, and we'll get a value for x. Okay, now once we've got the value for x, we can also calculate x prime. X prime will be equal to, based on this angle, we can calculate x prime. So I'll leave that for the next video. Thanks for watching. Hopefully this has been helpful. I'll see you next time. Thank you. Bye-bye.